Good morning. Thank you for the invitation to present at Gamma Technologies virtual conference. My name is Oded, and I'm the co-founder and CEO of Tour Engine Inc. The Tour Engine stands on three pillars. It is efficient, simple, and green, as will be described in the movie in the next slide. The movie follows Tour Engine cycle and serves as an introduction to both the technology and to the market opportunity.
The Tour engine is a patented split-cycle internal combustion engine that splits the conventional four-stroke cycle between just two cylinders, cold and hot. The cold cylinder hosts intake and compression, and the hot cylinder hosts combustion and exhaust. A proprietary crossover valve is used to transfer the compressed charge from the cold cylinder to the hot cylinder. As the cold piston moves down, a fuel mixture is drawn through the open intake valve into the cold cylinder. The valve then closes and the cold piston compresses the mixture into the shuttle through the cold port. A spark ignites the mixture, which flows from the shuttle to the hot cylinder via the hot port, expanding the mixture. Finally, the power piston moves upward, exhausting the combusted air and fuel out of the engine. Tour engines employ the same parts that have been at the heart of internal combustion engines for more than a century. These parts are inexpensive to manufacture, adopt, and maintain. The end result is a thermally optimized engine that is 40% more efficient, dramatically reducing both fuel costs and emissions. The Tour engine is a platform technology that could be used anywhere engines are used today. Tour Engine's market penetration strategy is to introduce a generator that provides both electricity and heating at the highest efficiencies and the lowest emissions at an affordable cost.
Returning to the three pillars, efficient. The efficiency increase potential is based on several independent calibrated GT power models. Simple, using the same parts as existing engines reduces development time and risk and lower barriers for commercialization. And green, a more efficient engine reduces CO2 emission, but in addition, we're measuring ultra-low NOx emission from our engine on the dyno. This slide touches on the first principles that are the basis of Tour Engine's increased efficiency potential. The Tour engine can reduce the two major losses of the engine, exhaust loss and cooling loss. Exhaust loss is achieved by decoupling the compression ratio from the expansion ratio at the Tour engine. For example, we can have a compression ratio of 10:1, transfer the compressed charge, but then expand 15:1, and by that have a true Atkinson or Miller cycle. Reduction in cooling loss is achieved by enforcing a superior thermal management strategy on the Tour engine. The cold cylinder that hosts intake and compression does not see combustion, and therefore there is the ability to reduce active cooling for a big portion of the engine. The transfer mechanism and the hot cylinder that hosts expansion and exhaust do need to be cooled extensively. However, because of the extra expansion at the hot cylinder, less active cooling is needed also at the hot side. The result is an overall reduce in cooling needs, although of course, like any other engine, the engine needs to be extensively cooled. The next slide describes our current development status and the near future plans. To summarize our current development status, our 5 kilowatt Tour engine is currently running on the dyno with over 200 hours of cumulative runtime. We're currently at over 28% brake thermal efficiency, which is best in class for this engine size, small engines. We're seeing a clear path to continue and increase the engine efficiency. We have no major durability issues, and this is a great achievement for a new engine design, which often suffer from durability issues at this stage of development. And we're measuring ultra-low NOx emissions out of the engine with more details in the next slide. The graph on the left depicts the indicated thermal efficiency in red and the engine out NOx level in green as a function of lambda, which is the air-fuel ratio. It can be seen that at moderate lean